An ant from Italy meets an ant from California, and they recognize each other as family. Scientists have uncovered a supercolony spanning continents where millions of nests cooperate as one. This is not fiction, it is the true story behind the ants that silently conquered 3 continents. But why do these tiny invaders accept strangers instead of fighting to the death? The answer challenges everything we know about survival and unravels a secret that could upend entire ecosystems. Argentine ants communicate with a language written in chemistry. Every ant's body is coated in a thin layer of waxy hydrocarbons, tiny molecules that act as a kind of passport. In most ant species, these chemical codes are unique to each colony, and they set off fierce battles when outsiders cross the border. But Argentine ants, after their journey out of South America, lost much of this chemical diversity. Their cuticular hydrocarbons became almost identical, a side effect of a genetic bottleneck that happened when only a few ants founded each new population. This accident of history erased the cues that once marked friend from foe. Now, an ant from a vineyard in Spain carries the same surface scent as one from a garden in San Diego. When they meet, there is no hesitation, just the gentle touch of antennae, a greeting reserved for kin. This chemical uniformity does more than prevent fighting. It allows millions of nests to merge into a single supercolony, stretching for thousands of miles. Unlike native ants, which are ruled by a single queen and defend tight territories, Argentine ants embrace a different strategy. Their nests hold dozens, sometimes hundreds of queens, each laying eggs side by side. This multi-queen system fuels explosive growth, turning small founding groups into sprawling societies in just a few years. The result is a seamless network where every ant is accepted, no matter how far she has traveled. The secret to their global conquest lies not in brute strength, but in a shared chemical signature, a passport that opens doors on 3 continents. In laboratories from Lausanne to San Diego, researchers set out to test just how far this ant alliance stretched. Naomi Tsutsui, Andrew Suarez, David Holway, Sophie Giraud, and Laurent Keller designed experiments to measure what happened when ants from distant supercolonies met face to face. The protocol was simple: introduce workers from different sites into a neutral arena and watch. In most ant species, this ends with locked jaws and flailing legs. But when a worker from Italy encountered one from California, there was no attack, just a brief touch of antennae, the universal sign of acceptance. Scientists scored each encounter, tallying aggression versus peace, and the results were clear. Across thousands of miles, Argentine ants greeted each other as kin. To uncover the roots of this unity, teams turned to genetics. Using microsatellite markers, Tsutsui and colleagues compared DNA from populations on 3 continents. The genetic signatures were nearly identical, a sign of shared ancestry and the bottleneck that erased their differences. Phylogenetic trees built from these data showed that ants from France, Japan, and California clustered together, forming a single extended family. Chemical analysis provided the final piece. Gas chromatography and mass spectrometry, known as GCMS, revealed matching hydrocarbon profiles from every nest sampled. The chromatograms, spiky graphs of each ant's chemical blend, lined up almost perfectly no matter the collection site. With behavior, genetics, and chemistry in agreement, the evidence left little doubt. The world's largest ant society is not just a figure of speech. It is a measurable, testable fact, grounded in the work of scientists who followed the trail from the lab bench to the global map. The journey of the Argentine ant began in the muddy floodplains of the Paraná River, where shifting waters and seasonal rains carved out their native home. For centuries, their world was bounded by the rhythms of South America, until human ambition redrew the map. In the late 1800s, as global trade intensified, the ants found new passageways hidden among the cargo of ships. Citrus saplings wrapped in soil left Buenos Aires for European nurseries. Ballast dirt scooped from riverbanks was dumped on distant shores as steamers docked in Mediterranean ports. Each shipment carried more than goods, it smuggled entire colonies across oceans. The first European sighting came in 1847 on the island of Madeira, a waypoint for ships between continents. From there, the ants advanced steadily, tracing the web of commerce along railways and coastal roads. By the turn of the 20th century, they had established a continuous network stretching from northern Italy along the French Riviera, through Spain, and into Portugal. Today, this European supercolony runs unbroken for nearly 3,700 miles, the longest cooperative ant society ever recorded. The same story repeated in California. Ants arrived in San Francisco Bay, likely hidden in the soil of imported plants or packed in the crevices of wooden crates. As the nursery trade flourished, so did their numbers, spilling down the coast from San Francisco to San Diego. Ships crossing the Pacific carried them onward to Japan, where genetic studies now confirm their presence as part of the same extended family. Human commerce, relentless and unintentional, stitched together a living network that spans continents. The ants traveled as stowaways, but what emerged was a global colony, one that grew with every shipment, every rail car, every planted tree. The arrival of Argentine ants triggers a silent upheaval in the places they invade. Where their supercolonies settle, native ants vanish, sometimes within a single season. In California's coastal sage scrub, biologists tracing ant trails through the undergrowth found nearly every native species gone from invaded sites. Transects that once showed a patchwork of harvester, carpenter, and native fire ants now record a single, unbroken line of Argentine workers. This collapse ripples outward. The coast-horned lizard, once common in these habitats, depends almost entirely on native harvester ants for food. As Argentine ants overrun the landscape, harvester ant populations plummet, and with them, the lizards fade from view. Field ecologists recall the suddenness of the change, a territory rich with lizard tracks one year, empty the next. The disruption doesn't end with predators. Argentine ants form alliances with aphids and scale insects, tending them for sugary honeydew. In return, the ants protect these plant pests from native enemies, allowing their numbers to swell. This shift alters plant health and pollination patterns as aphid outbreaks stress local vegetation and crowd out mutualists that once kept the ecosystem in balance. Researchers tracking these changes see a chain reaction. Native ants displaced, predators in decline, plants under siege from unchecked sap feeders. The supercolony's spread is not just a story of conquest, but of unraveling connections. Each new territory claimed leaves a record of what's been lost. Field notes and survey data chart the damage, grounding the global sweep of the Argentine ant in the real and often irreversible harm felt by the communities they invade. Attempts to wipe out Argentine ants rarely succeed. Standard eradication tools such as baits and pesticides barely dent their numbers. The reason lies in their structure. What looks like a single nest is actually one node in a vast, unbroken network. Kill off a patch in a city block or vineyard, and workers from neighboring nests flow in to fill the gap. Localized control is like patching a leak in a river. The current simply finds another way. Yet there are places where prevention works. New Zealand has kept Argentine ants from gaining a foothold by enforcing some of the world's strictest biosecurity at its borders. Every year, inspectors intercept shipments crawling with ants, halting invasions before they start. These rare victories come not from fighting the ants after they are inside, but from blocking their entry at the threshold. For most regions, though, the colony's reach continues to expand, undeterred by conventional barriers. Estimates for the Argentine Ant supercolony in California reach into the realm of the staggering. Scientists calculate that as many as 1 trillion ants occupy the coastal corridor from San Diego to San Francisco. This number, so large it defies imagination, represents not just a population, but a living network that rivals the scale of some of the world's greatest animal migrations. Each patch of soil, every garden and city park becomes part of this vast collective. The supercolony's reach is measured not only in miles but in sheer numbers, an army that outnumbers humans by more than 100 to 1. In the global tally, the Argentine ant stands as one of the most populous animal societies ever recorded. Right now, 1 trillion Argentine ants reshape ecosystems from California to Europe, proving that unity, not size, can tip the balance of nature. As global trade accelerates, the next supercolony may already be on the move. Sometimes the world's most profound invasions happen in silence. What would you notice first?